Welcome to the course E8351 Digital Logic Circuits. Unit number 1, Resistor Transistor Logic. In short, we call it as RTL. So at the end of this section, one can able to understand the various number systems and the operation of various digital logic families. So here I have shown the introduction of RTL. So RTL, it is one of the digital logic family circuit. So RTL is one of the basic logic circuits in the digital logic families. Okay, so it is an bipolar saturator device. So it is called as bipolar junction device also. Okay, so it has two junctions, so that's why we call it as bipolar junction device or bipolar saturated device. Okay, so here the RTL logic is popular because of its simplicity. Okay, so the designing this RTL circuit is very easy to design, and also it is very easy to implement. So its working function and all, it is very easy to study. Okay, so that's why the RTL logic circuit is called as a simple circuit. So here the RTL circuit consists of resistors at the input and transistors at the output side. Okay, so here we have two inputs A and B, and we have a single output, that is Y. Okay, so transistors are used as a switch. Okay, normally we know the transistors are mainly used as a switching device. Okay, so here we are using two transistors, and at the input side we have resistors connected, and from the transistor we are taking the output at the output side. Okay, so the emitters of the transistors are connected, both the emitters of the transistors are connected together to the ground, and the collector terminals are tied together and given to the supply through the resistor RC. Okay, so the input supply voltage VCC is given to the collectors of the both the transistors. Okay, the collector resistor is known as passive pull-up resistor because through that passive pull-up resistor only we are going to give the input, that is VCC. It is called as pull-up resistor. Okay, so here the diagram of two input RTL NOR gate RTL transistor circuit is shown. So as I have told you, here we have two resistors in the input side, and from the transistors the transistor will be delivering the output, so that is Y. So it is taken from the collector region of the two transistors. So here we have I have assigned the two transistors as Q1 and Q2, and A and B are the two inputs given to the base of two transistors, and Y will be the output. Okay. So when both the inputs, that is A and B, are 0, the output will be 0. Okay, so here when you look at the circuit, so here if you are giving both the input A and B as 0, the output will be obviously it will be 0. Okay, so it is not enough to turn on the gates of both the transistors, so the output will be obviously it will be 0. Okay, so transistor will not conduct, and the plus VCC voltage will not appear on the will appear at the output, hence the output is logic 1 or logic high at terminal Y. Okay, so when any one of the inputs either A or B is given high, that is 1, then the transistor will be high gate input and will be turned on, so the supply voltage directly goes to the ground and the output will be 0. Okay, so here the next circuit, that is the 3 input RTL NOR gate is shown. So here 3 input means we will be having 3 input resistors, and obviously we will be using 3 transistors Q1, Q2 and Q3. Okay, so both the circuit diagram connections are almost same, and it will be delivering the same output. Okay, then limitations are when transistor is switched on, the power dissipation increases as the current flows through the base and collector, as the RTL gate has poor noise margin, poor fan out, and the propagation delay is much more high. Okay, that's all about the RTL design. Thank you.